Hello everyone, welcome to our channel Career Talk. My name is Suresh Sharma. I'm an agile consultant based in Netherlands, and today we are going to discuss the top 10 most asked Scrum Master matrices interview questions which we gathered from several real interviews. The questions may look simple, but believe me, they can be really tricky if you don't understand the concept well. So don't skip anything and make sure to watch till the end. And to help us with this discussion, we are glad to have Devika Joshi from Poland with us. She has over 10 years of experience as a Scrum Master, working with clients across India, Australia, USA, and Poland. But friends, before we start, please subscribe to our channel. And if you enjoy our quality content, don't forget to smash that like button and share your thoughts in the comment section. All right, let's get started. Devika, thank you. Welcome for joining us today. Devika, over to you.
Thank you so much, Sunal, for having me. And of course, as I always say, it's always a pleasure to give something back to this beautiful platform that helped me so much. So I'm super stoked and very happy to be here. Thank you.
Great. Okay. So the very first question is, what is velocity and how do you use it without turning it into a performance metric?
Okay, so velocity ideally is the sum of story points or any other estimate that you're doing for all product backlog items successfully completed by the team that meet the definition of done during a single sprint. Now, you don't use that for forecasting. As a reliable baseline, what we do is we take average velocity. So that means the average velocity over 3 to 4 sprints. I would recommend maximum 4 because after that things go stale. So that's my personal recommendation based on my experience. So how do we calculate that? Story points from the number of sprints divided by the number of sprints, so you get an average velocity. So that is the baseline. It is used, this average velocity, in sprint planning to set realistic commitments and for release planning or forecasting to predict when a set of features might be delivered to the stakeholders. Now, to use it the right way, that is without turning it into a performance metric, you must treat it as a pure planning and forecasting tool to help the team determine realistic commitments for future sprints and to estimate completion timelines for larger releases. It must not be used to compare teams or evaluate individual performances or pressure the team to increase the number. And, why are you just adding these many sprint points? Hey, challenge, add more. So you should not do these things. And in my experience, what triggers this thing is also sometimes seeing individual sprint velocities over time by other team members. So they start comparing that, oh, in previous sprint they completed 35 points, but this time just 30. Why? So for me, what has worked is showing them average velocity over sprints and not just individual velocities. That has helped. And also educating my team members, the developers and POs, that this is not the right metric for performance. So if this is not, then what is then? So the right performance indicators that I suggest my teams to use instead of velocity are predictability. How predictively the team is meeting its commitments, the churn rate, that is basically how many things came inside the sprint and how many went outside. So both the numbers, the sum of both the numbers divided by the total original forecasted points, into 100, so you get a percentage. And sprint goal achievement, so there are various ways you do sprint goal achievement. Probably you can go to your PO so they can give you a percentage, or sometimes they could just say that, hey, out of these many, this much goal was achieved. So this is the percentage, or this is whatever metric they like. So these should be the real metrics. Now, time for yeah, so this is how you actually measure velocity properly and ensure that it is not being used in the wrong way. Now, time for Devika's insights that I have gotten from my experience. You should look out for sudden spikes or plummets in the average velocity trends as well. Now, and it's not necessary that they're good or bad. Like, for example, if there's a sudden spike in the average velocity trend, it might also tell you that there, say, there's a plummet. So there could be a major unplanned dependency, or a team member has been absent, or a successful process improvement has been there. So it's not always bad to have a plummet. On the other hand, spike might mean that the team is doing known work, or a new team member was added. But it could also be due to an anti-pattern called story point inflation that the team artificially does by assigning artificial inflated story points. And if you are feeling that, that means your team is internally getting stressed of delivery. And that is why your team is doing that. So watch out, because a good Scrum Master can tell you what the velocity trends are, but a great Scrum Master can tell you exactly why the trends indicate so. So that is it, Sunand.
Wonderful, Devika, for that great elaborate answer. Wonderful. I thoroughly enjoying it. Great. So let's move on to our second question, which is what is capacity and how is it different from the velocity?
Okay, so capacity is an estimate of the total available working time. Typically, we use hours for a team, which is available during a sprint when you're calculating that. So it is calculated by taking the total time available, that is the team size, into the sprint duration, into the working hours per day, and subtracting the planned non-working time like holidays, training, admin tasks, or meetings from it. And it is used in sprint planning to inform the team's commitment by showing the available effort, which they then can cross-reference for their historical velocity to make a realistic commitment of story points. And it is mainly used during sprint planning to determine the input available effort for the upcoming iteration. So capacity, what is the difference between capacity and velocity? Capacity focuses on input, that is available time and effort, and can change from sprint to sprint, and it's completely fine. Whereas velocity focuses on output, completed work measured in story points. And typically it uses an average past performance for a more stable prediction. Now, time for Devika's insights, my experiential insights. Many team in this metric, they can suffer from resource allocation trap, which is an anti-pattern where they use the capacity that is available hours to commit. And this is often a trend in non-agile teams, or teams just getting used to agile. And this is something that I experienced when I came into a team which I was supposed to make agile. So they were just committing based on hours. And why is it not ideal? Because it ignores uncertainty and historical performance, and also the velocity, of course. So how did I solve that? I solved it by shifting from firstly hourly estimates to story points, and then using a metric, another metric called focus factor, which is average velocity. Again, I use past 4 sprints personally, divided by average capacity. And to establish their true efficiency, I multiply this ratio that I get into the available working hours, that is like the available current capacity. And then you can get the number of story points that you should be committing. So that's a more predictable way to forecast and really use both of these things together nicely. Also, you can use the focus factor and see this as a trend. And if the focus factor is dropping, that is a indication to you as a Scrum Master that there's a deeper problem within your system, like excessive unplanned work or context switching, and maybe you should take it up with your team. All right.
Wonderful. Thank you, Devika, for that. Okay, let's move on to our next question. The next question is, how are you going to calculate your sprint predictability, and what are the different factors that might affect its accuracy?
Okay. So sprint predictability, and sometimes in other teams that it's also called sprint scope completion rate. It is a rate of how predictably the team is committing to a sprint. So how do we calculate it? It is number of points completed at the end of the sprints, the actual points divided by the points committed at the start of the sprint into 100. So you get a percentage. Now, why is it used? It's used for tracking the consistency of commitment, and it's actually a true performance matrix, right? And it basically helps the team and stakeholders build trust in the forecast, and the goal is a high stable rate that is anywhere between 80 to 95%. And you primarily use it in sprint review to assess the outcome and sprint retrospective to identify process improvements. Now, a rate less than 80% means you're overcommitting. A rate over 100%, that means you are undercommitting. A good range is between 80 to 85%. The factors that can distort predictability are change in scope, adding or removing items mid-sprint, poor estimation, unforeseen technical issues or dependencies, unplanned work. Example, you have some kind of production support coming up, and changes in the team capacity. Somebody has a sick leave or something like that. So that's where you see the changes. Now, time for Devika's insights. This is not supposed to be a consistent 100% always, the predictability rate. So if you're getting like 100% perfect rate over some sprints, it's not actually good, it's actually bad, because it's silently telling you that the team is making artificially created perfect commitment, and they are actually under committing in the way, because if they can make this perfect line, that means they know exactly how much there has to be committed, and they're doing under that so that they can do it. So maybe you need to have a word with the team if it is 100% over various sprints. That's it, Sanant.
Yep, true. Thank you. Okay, so let's move on to our next question, which is what's the difference between a lead time and a cycle time? And most importantly, how you're going to shorten them.
Yeah. Okay. So lead time is the total time from when the customer or the stakeholder makes a request and the item enters the backlog until the item is delivered. That is total time the customer waits. If you see why is it there. So technically, the total time from when the request is made, product backlog, item enters the backlog until delivered. The formula is the date of delivery or date delivered minus the date item entered the backlog. So that is how you calculate the lead time. Cycle time, on the other hand, it's the time from when the team begins the active work on the item and the item moves to in progress. That is when it starts to be calculated, right? Until the time it is delivered. So basically what it is, the time the team spends working on the increment or the story or something like that. The formula is the date of delivery minus the date it was started in progress. So that is the cycle time. So they both are metrics used to understand the speed and flow of your value delivery. So lead time measures the customer's wait, while cycle time measures team's execution efficiency. And lead time and cycle time are primarily used in sprint retrospectives to inspect and improve process efficiency, and in sprint review to communicate delivery speed. Now, time for my insights. When you do lead time minus cycle time, you get something called an organizational waiting time, which is basically nothing but wasted time. And you can shorten both lead time, all the three, lead time, cycle time, and organizational waiting time by first limiting the work in progress to improve the focus and flow. Then also you should think about breaking down work into smaller batches. You can also look at automating testing and deployment. and basically streamlining the handoffs that you have. And it's also a good idea to track cycle time per workflow step. That is, cycle time of, say, how much cycle time is of a particular item, say in progress or say in QA, because that will make you identify where is the bottleneck precisely located, or where is the organizational constraint. So that's it, Sunand.
Okay, wonderful. Thank you, Devika. Okay, so let's move on to our next or fifth question, which is what does a CFD or a communicative flow diagram shows basically, and how you're going to interpret the bottlenecks in CFD?
Okay. So a cumulative flow diagram is an area graph where the x-axis is time and y-axis is the count of work items. And there you will see different color bands which represent different statuses: to do, in progress, QA, done, whatever, depends on what statuses you have. And it basically shows the total number of items that have entered the state up to a given time till it's like done or something like that. So it is used because it visualizes three key metrics simultaneously. First is work in progress. So the vertical distance between the start and end, that is how it is represented of every stage band. Cycle time and lead time is also shown there visually by the horizontal distance between start and end of a set of stage bands. And throughput is also shown there, which is basically the slope of done line. It is used by the entire team and stakeholders to analyze and improve the workflow. And cumulative flow diagram is primarily used in sprint retrospectives to inspect process flow, stability, bottlenecks, and also the daily Scrum to monitor flow. And the sprint review also uses it to communicate progress to stakeholders. How do you see bottlenecks in it? There's a widening vertical gap in any stage band before done. That means if it is widened, that means there's some kind of bottleneck, and that means the items in that status are entering faster than they are leaving. So now, time for my insights, Devika's insights. So apart from all this, CFD can also help you uncover various anti-patterns visually. And that's why it is actually a beautiful tool to use. So one, I already told you that you can identify bottlenecks in different stages by seeing the widening vertical gap. That is one, right? The other thing that you can simultaneously see is the start, sorry, stop starting and start finishing anti-pattern, or in other words, work in progress overload. So the top line, that is work started or to do, has much steeper slope than the bottom line, that is done. So if you see that visually, that means the team is starting too many things without finishing them, leading to maybe context switching or slow overall delivery speed. And what you do as a remedy is you freeze the top of the backlog and strictly enforce work in progress limit on active columns to enforce the team to pull only when the things finish and they are empty enough to be taken up. Yeah, and fine. You can also see batching, another anti-pattern. So basically, this is very visible. The bottom line done has step-like pattern. So that means long flat periods and followed by sharp vertical jumps. So, and like this, like what a step is usually. So that means if you see that in the diagram, that means your team is holding a ton of completed work and only updating its status in large batches. So maybe at the end of the sprint, which is basically hiding the true flow and makes matrix that you are measuring unreliable. So what is the remedy here? You enforce a strict definition of done as soon as the item is finished. You update the board, encourage them to update the board, and put a little bit of stress in the daily stand-ups or retros on delivering value continuously as soon as possible and moving things to done. You can also look at, are they actually, are the stories the right size, or they're encompassing a ton of things in there that could, no, that could also be the thing here. Okay, and the last thing is scope creep. The very top of the entire chart, total items or committed, rises sharply, and during the sprint period time. So that means suddenly scope creep has entered your sprint. So here, of course, you have to do the churn if in case you are in a very volatile or chaotic project. You can also look at prioritized lanes in case you are working in a chaotic environment, because let's face it, sometimes, especially when you're near the release, you could not say, hey, user feedback implementation, we can actually do it next release. No, you cannot. But if you are not in such situations, ideally you should protect the sprint backlog from changes once the sprint starts, and you should encourage those things to be taken up the next sprint. So yeah, that is it, Sunand.
Wonderful. Devika, you want to take a sip? It's okay. By the time, let me do some promotion. So, yes, friends, if you are looking for any sort of mentorship, or if you need some guidance on your career, on your interview preparation, or if you want to move abroad, you can schedule a one-to-one call with me through our TopNet link. And if you're interested in transitioning into a Scrum Master career role, you can join our 6 weeks hands-on Scrum Master cohort program, open to everyone, where we teach everything from scratch, regardless of your background. And yes, you can find the link in the first pinned comment. You can reach out to me in case if you're interested. Okay, enough promotion, Devika. Let's move on. So next question is on throughput. So what is throughput, first of all, and how is it different from velocity? A lot of people still got confused. Yeah.
Okay, so throughput is the number of work items, that is, it could be stories, tasks, or features, whatever, not features, but stories, tasks, bugs, etc., which are completed over a given period of time, per week or per sprint, if you're talking sprint specifically then. So the formula is the number of completed items per time period. It is used as an objective, non-estimated measure of delivery output, especially when you're talking Kanban, they use it rigorously. It is also a key for flow analysis and forecasting using some probability methods like Monte Carlo simulations, etc., as it doesn't rely on story points estimation. It is also used for forecasting and to calculate other flow metrics like cycle time, and often, it is discussed in cycle time and lead time, etc., are discussed during workflow review. Now, the throughput measures the count of items, objective, while velocity measures the size of items, the story points, subjective. Okay, so that is the difference between both of them. Now, time for Devika's insights. Throughput is often favored by teams practicing pure Kanban flow because it's less prone to manipulation if you are slicing your stories correctly. That is vertical slicing. But of course, if that's not there, you can have umpteen number of stories, right? If you're not slicing it the right way. But if you do, it avoids the overheads of estimation, and that is why, if you would have thought about a controversial topic called no estimation movement, that actually favors throughput for forecasting. But this only works correctly, again, if your stories are vertically sliced, which prevents inflation, and completed item count is more reliable. So that's it, Sunant.
Okay, great. Okay, so next one is little interesting. So how you're going to track the work item age, and why does it matter?
Okay, so work item age is the time an item has been in the current workflow stage but hasn't been completed. So formula to calculate that is current date minus the date item has entered the current stage. It is used primarily within the daily stand-up to focus on team on completing the oldest work first, and thereby reducing the overall cycle time. And why is it risky to have aging work is the longer the item sits incomplete, there's a higher chance that it will require some kind of rework or lead to some kind of technical debt, cause some kind of scope creep later, or sometimes can also become irrelevant, right? So in highly optimized teams, work item age becomes primary decision point, following the oldest first, which is sometimes also called first in, first out policy, because addressing the oldest, highest risk item is the most effective way of improving flow. Now, time for Devika's insights. If an item exceeds more than 50% of the item's average cycle time, start bringing it up in the stand-ups or asking what are we doing for this item. Furthermore, never let work item age be the sole priority for the product owner, because the team must still ensure that we are working on the highest business value item that is ready, even if that means compromising a slightly older, lower value item that exists elsewhere. So prioritize the flow, oldest first, only when the value is actually equal. Value should be the primary measure. That's it, Sunand.
Great, Devika. Thank you for that. Okay, so let's move on. The next question is how you are going to visualize the flow stability over the multiple sprints over the period of time.
Again, you can also use cumulative flow diagram for that. I mean, when you increase the timeline over a few sprints, the period you could see that. So I primarily use cumulative flow diagram for that. So how do you observe a good flow is basically a very parallel flow. So you use CFD by observing how parallel the bands of different states are. So the CFD plots the count of work items that have entered each stage of the workflow, as we spoke, like how many are in progress, to do, testing done, whatever, over different sprints if you adjust the time scale effectively. And stable flow is good. What that means is that the band's lines for the workflow stages run mostly parallel to each other, and that indicates flow stability. This means the team is completing work in a consistent and predictable rate. So there is low volatility, variability, whatever you say. Unstable flow, which is bad, is when the lines are not parallel. The bands widen or get narrow significantly, and that signals instability. So widening bands often, like in progress, QA, or anything which is not done, indicate a bottleneck, as we discussed earlier, or a constraint, and the work is entering the stage faster than it is leaving. While on the other hand, if anything narrows down, that indicates a successful process improvement, or that the team is maybe an anti-pattern, starving the system of work. So that is my answer, Sunand.
Wonderful, Devika. Okay, let's move on to our next question, and which is like which matrices should you use in which Scrum event? So it's a little tricky. Like every event will have some sort of matrices which you can use over there, but let's not many people are aware about it. So how you are going to answer this, Devika?
So, okay, I'm not going to explain different metrics because I I have previously, so I'm not going to put time in there. So let's get into it straight. While you are doing sprint planning, use velocity and capacity and focus factor, right? We already talked about this briefly. And while you're doing daily Scrum, see work item age, sprint burn down chart. You can also use a cumulative flow diagram in case you can see some widening gap or something like that and you want to address that. So cumulative flow diagram is also a very good thing to do. During sprint reviews, you use things like sprint predictability. By the way, sprint predictability, if in some sprint planning sessions, you can also use in case you are also telling about the previous sprint before entering into new one. So it could be used both in sprint review as well as planning. So coming back to sprint review, sprint predictability, that is how much percentage of work was really committed versus delivered work, velocity, and release forecasts, so that the stakeholders know what they really have to expect regarding how the project is going on. And the team may also report on number of resolved production defects, that is defect rate. You can also think about escaped defect density. You can think about those. In sprint retrospective, you use cycle time, lead time variability, sprint predictability, velocity trends are also important to be inspected, and to identify systemic impediments that they could be. You can again use the defect or escaped defect rate as a key quality metric. You should always regularly validate definition of done, and whether your definition of ready is up to the mark or not in the retrospectives. I highly many times encourage using cumulative flow diagrams again, because it's a single tool that tells you so much about the sprint that happened, right? And you can also use focus factor in sprint retrospectives to inspect the efficiency loss, if at all. See, again, if there's a drop in the trend of focus factor, and maybe you can use that to initiate a root cause analysis of distractions or waste. So that is it, Sunand.
That is it. That is all. That's too much. Thank you, Devika, for sharing such a valuable insight. And to all our friends watching, if you enjoyed this session, I have no doubt you definitely enjoyed this session. And if you found it helpful, please smash that like button and subscribe to Career Talk for more quality content. And don't forget to share your thoughts or questions in a comment section. We'd love to hear from you. So for now, this is Suran Sharma signing off along with Devika. Thank you for watching, and we'll see you in our next session very soon. Thank you, Devika.
Thank you, sir.
Thank you.